In this question, we're asked to approximate log 34 without a calculator. The first thing to remember is that log with no base written means log to the base 10 of 34. So writing this as an exponential statement, we get 10 to the power of what is equal to 34. Now we know some useful information to help us solve this, or approximate this, because we know that 10 to the power of 1 is equal to 10, and we know that 10 to the power of 2 is equal to 100. So that means our unknown, log of 34, must be between 1 and 2. But where between 1 and 2 is it? Now it might be natural to assume that perhaps it's about 1.3. Log 34 is approximately 1.3 seems like a sensible approximation because 34 is about 0.3 of the way between 10 and 100. But actually the real value of log 34, which you can check if you put into your calculator, is 1.53, and then those decimals carry on going because this is an irrational number. So why is it a little bit higher than we thought? Well, it's because of the nature of exponentials and the fact that exponentials grow more quickly the larger the power. So if you think about what happens of powers of 10, we start with 10 to the power of 1 is 10, and then we get 10 to the power of 2 is 100, but then 10 to the power of 3 is 1000, and then 10 to the power of 4 is going to be well off the top there at 10,000. They get very big very quickly. And what that means is we get this sort of curved shape going between the points. And because it's a little bit flatter at the early stages, it takes a little bit longer to get there compared to the second half, which rises much more quickly. So this 1.5 about here on this graph represents the fact that it's going a little bit slower than we might think to get there. And this generally happens with logarithms. They are always a little bit bigger than you think they might be.